Okay. Good morning, guys. Let us start the session. So, how many of you here are like freshers or like all of you are experienced? Guys? Okay, good. Yeah. So just wanted to know about you guys. So we'll interact later. Slowly we'll start our interactions also. I want this class to be as interactive as possible. If you're not getting something, you just stop me anywhere, you ask questions. Okay, that's all right. Even if you don't have, I think coding experience is not required for this course. Mostly all you have to do is you need to practice a lot of things. You need to understand a lot of things, so which I'll be explaining. Okay. Yeah, good. Okay. Okay. So let us start the class today. So today we are going to see introduction and evolution of cloud. So before we get into the cloud, I want to cover a few basic concepts which we use in IT industry in the background, because that is what led to the um, development of cloud, or that is what was the past, and from there people have evolved to cloud what is today. So we'll see few basic terminologies that will be required while understanding more about cloud. So the first topic for today is client server architecture. So what is a client, what is a server, and what is a client server architecture? So let us start it. So what is a client? A client is any computer hardware or software device that requests access to a service provided by server. For example, if you want to book a movie ticket, so you go to Book My Show app. Okay, now this Book My Show app is on your mobile. Now this alone cannot book your ticket. If you do not have internet connectivity, you cannot book your ticket. So when you request this Book My Show app to book tickets, what it does in background is it connects to a server which is hosted somewhere, Book My Show server, and it fulfills your request. So in this scenario, you are a client to Book My Show, and your mobile application is a client application for Book My Show. Okay, so these client applications generally they request servers to perform some activity that they themselves cannot do. So in our case, our client application, that is Book My Show application, requests the server, Book My Show server, to book ticket based on whatever you have selected in the UI in the client side. So once you have selected in the UI that okay, book F3 4 5 6 seats, then this same request, whatever you have requested your mobile application, is put to the server. So this client application requests the server to book seats for you. So you understand that this is the client server architecture that we are talking about. So in client server architecture, there will be a client, and the client requests the server, and server responds. So once your tickets are booked, the server will respond saying you have successfully booked your tickets, and these are your seat numbers. So suppose some problem occurs, it is not able to book. It will say, it will show you error, right? So your ticket booking could not be processed due to internal error or technical error. So whatever it is, the server will respond based on the request. Okay, so you're understanding that client server architecture. So we have a client, we'll have a server. Client always requests the server, and server responds. Okay, now the assignment, so for this topic is, so I'll be giving you assignments. It's up to you if you do it daily or you can do it weekly. Monday we'll review all the assignments, so we'll again have a discussion on every Monday on what you have done or gained knowledge on the assignment. So the assignment for this very topic is types of clients available. So you just have to Google it. You will understand the different types of client available, like thin client, thick client. So when do we say it's a thin client? When do we say it is a thick client? What are the other types of clients available. So this you please do it, and we can have a discussion on Monday, so that we again refresh the same topic and we have a discussion. Okay, now coming to the next topic, what is a server? So a server is a computer program that provides service to another program or user. Okay, as we discussed in our previous example, that book my show, when you have to book a ticket, your client application will request the server and server will respond. In this scenario, what is there could be multiple types of servers available with your book my show. So the types of servers are, these are just examples: application servers, cloud server, database server, domain name server, file server, print server, proxy server, standalone server, and web server. So for example, if a server is hosting an application, it is called an application server. Okay, if a server is hosting a cloud UI of a cloud, then it is called cloud server. If a server, we have database, so for booking tickets, it must add some entry to the database, right? So it must tell that, okay, if seat numbers, suppose A3456 are booked, so when it has to book it, it has to add that entry in the database that they are blocked, so that nobody else can book it. So so all this data is kept in a server called database server. Okay, then we will have domain name server. What is a domain name server? Domain DNS server is your DNS name to IP address matching. Suppose when you type www.google.com, you know the URL of Google, that is google.com. But whenever communication happens, it happens through IP address. So that mapping of the name to IP address is handled by DNS server. When we'll be going through networking concepts, we will dig deeper into it. But for now, you just have to remember that for each name that you type in your browser, each website, it could be IRCTC, or you could go to any URLs, like you can open Facebook or Instagram. So each URL will have IP addresses in the backend. So your this name to IP address mapping is taken care by domain name server, DNS server. Okay, the next type of server is file server, in which we store and retrieve files. It could be thought of like your Google Drive is a type of file server. You just save your files there, and whenever you want to, you retrieve it from there. Mail server, again, Gmail is a example of mail server. It is used to send mails from here and there. So you have to request, using your Gmail account or browser or app, you have to request the server to send a mail, and whenever a mail comes, it automatically syncs it to your mobile. So that is a mail server. Print server, it is generally there in corporates. You will see that you need to give a print, and it will be a network print. Printer will be there in network, and once you print it, the print server will take all the printing requests, and it will queue it, and based on the queue, it will print out, and you can take your prints there. Okay, generally we use print server if we have to print, if there are a lot of people, and a lot of people have to print a lot of pages. Okay, so if you are at home, you will not be using a print server, you'll just use a printer. But when you're in an organization, we generally use print servers. Okay, proxy server. What is a proxy server? Proxy server we use in organizations to block traffic or to manage traffic. So if you want to set up a organization, if you want to set up a company, and you want that in your company, whoever is working, they should not be able to access certain pages. Like they should not be able to, they should not be accessing their personal Gmail due to security reasons. They should not be accessing their personal drive due to security reasons. So all this traffic, internet traffic that is flowing in and out of your organization, you can manage it using proxy server. So proxy server is used for managing the internet traffic, or managing the network traffic based on certain rules. So we can define rules in that. Okay, block these websites, block these users from accessing this, allow these users Gmail, like few users you can allow Gmail based on their request. So all this we can manage in using proxy server. A standalone server is again, it's a separate server. We can use it for any application hosting or something. Web server, if you want to expose your application, so you have hosted application, you have written some piece of code in your server, it is there in server, but you want people to access it from around the globe, you want to expose it to internet. So in those scenarios we use web server. So when we get into details of it, we will implement and we'll also see web server, how web servers are today, and how they have been replaced, how servers are there in cloud today. Okay. And what is the equivalent of web server when we'll be discussing about Docker and Kubernetes. So we will go through the basics of Docker and Kubernetes in our training. We'll have few sessions on that. I will make sure that you have hands on and you actually implement and see. I'll give you scenarios, I'll explain. Okay. So then also you will use the concept of web servers. Okay. Now coming to again client server architecture. Now client requests a server something over HTTP. So what is HTTP in this scenario? Can anyone guess? You just have to unmute and just talk. Anyone?
That is like web requesting. Like for example, we need to provide DNS server, right? We need to provide some such right in that time using HTTP.
Okay, so when we say a client is requesting something to server over HTTP, what exactly am
Yes,
I talking?
HTTP is like a like for example, how do I say? Mm,
It's a we can say it as a network between machine and
So it's okay. Let me explain. So exactly, HTTP is called as protocol. Okay.
yeah.
So what is a protocol? So like we are communicating, I am talking in English and you are able to understand, you are again replying in English and I am able to understand. Similarly, when a client and server they interact with each other, they cannot obviously interact in human readable format, so they talk over protocols. So HTTP is one of the protocol which we use in client server architecture. So they can communicate between themselves. So when a client has to request something to a server, there can be multiple protocols. So one of the protocol is HTTP, and whenever you want to book something, go to a website, we use mostly HTTP for all the communications. Okay. So HTTP is a protocol and server will respond over a protocol, that is HTTP. So the assignment for this topic is you just have to go and find out what are the types of protocols available. Could be TCP/IP and other types, and where do we use it? Just have a general idea so that we can again discuss it when we are going into deep. Okay. So clear till now, what is a client, what is a server, what is client server architecture?
Okay.
Yeah. So let us get into next topic. That is, what is on-premise? So if you have heard this term, good. If you are hearing it for the first time, you're going to hear this in the industry a lot, because on-premise is the older version of the previous generation of cloud. So today, as we are talking cloud, the previous generation, a decade ago, everything was on-premise. There was no cloud. So let us see what on-premise is. Can someone guess what this image is?
Server.
Mm, yeah, like when we use it in day-to-day life, what do
Yeah,
we call it?
CPU.
Yeah, we call it a
Data
CPU.
center.
It's a simple CPU that we use it in our homes. Okay. So if you want to have a desktop in your home, you just have to go and get a CPU with your configurations. You can tell him that put 32 GB of RAM and i5 Intel i5 processor and some 500 GB of hard disk. Okay, and you will give some USB slots for CPU for your keyboard and mouse. You will give a VGA cable output so that you can connect your monitor. So this is a CPU. Now on this CPU you can host an application. If you write application, suppose you wish that I want to create a website like IRCTC. Okay, you can create it. You can very much create it using any language you want, and you can host it in your laptop, in your CPU, let us suppose. Okay, but how many requests can the website serve? Suppose 10 people want to book ticket, they will be able to book it. Okay, but what if you have 100 people want to book ticket? Can the CPU take that much of load? Because it does not have the required memory and compute to process 100 requests at once. Okay, imagine 100 requests to be like 100 different processes running. So those many processes cannot be processed because it has limited memory and CPU. So what do we do in this case? You have an application, but you want you hosted it, 10 people, they're accessing it and they're booking tickets and it is working fine. But now you want 100 people to book tickets using your application. So in those kind of scenario, we go with a server. Okay, a server is similar to CPU. It looks something like this. Okay, the top one is the front end of a server, like how it looks from front, and the bottom one is how it looks from the back. Okay, so this server also have memory, it will also have CPU, it will also have storage, that is hard disk, but the configurations will be higher. It can have up to 256 GB of RAM. Imagine with 256 GB of RAM, it can have up to 100 V cores, CPU cores. CPU generally we describe in cores. Okay, can have 250, 6 GB of RAM and 100 plus cores. So depending on configuration, this also you can customize and get it. You can go to vendors and you can get server with configuration depending upon your requirement. Suppose you want 100 people to use your application, then you go and tell, okay, 256 GB RAM will be fine for me and 100 V cores are good enough to start. And then you take your application, you format this server similarly how you format your CPU. How do you format your CPU? You take a ISO image, Windows or Linux, you make it bootable, you format your C drive with the OS and you can use it. Similarly, you can attach a pen drive to this server. It will also have USB ports. Okay, and you can format this server and you can put your application on this. So this generally we call it as bare metal server. Since there are different types of server, people get confused like whether it's an application server or database server. So when I say application server, database server, I'm talking about the application, the software as a like software service, the process which is running. But when I say a bare metal server, it is the physical server that I'm talking about. Okay, so this is a terminology which we generally use in industry. So these are the slots names. You can go later like and get into details about different types of slots and why they are used, but generally mostly they are used for the LAN slots are used for connecting LAN cables. USB slots are used for if you want to connect a CPU, keyboard or mouse to this server, you can connect it using those. A VGA cable is used to connect monitor and check. There will be multiple cooling fans attached so that the server is not heated up. Okay, there will be hard disk in it for slots to replace those disk. So you can go and check more about different types of servers. We get servers of HP, Dell servers. Every company have their own servers configuration. You can read more about it. So you understand right now. So when we use it for personal use, we call it as CPU, which we use it in our homes. But when we have an organization and we have to run some application, we go for servers and we call those as bare metal servers. Okay, so this is what it is. So you can go and check what are the types of ports available. Okay, now where do we keep this server? So you see the server is just sleek. It is so thin and sleek. It looks like a DVD player old days. So we keep all the servers in this kind of racks. We call it as racks. Okay, a single rack we can mount up to 10 or 15 depending on again rack size. So we put servers in these racks. So we just take the servers and we put it. So this is how a rack looks in an organization. So in these racks we have multiple servers. Suppose you have application which now your application got popular and now 1,000 people want to use your application and they want to book tickets. Okay, so when it was 10 people you are using CPU, when it came to 100 people you used one server. Now you have to make sure that 1,000 people use it. So what do? You get 10 servers like that and you mount it in a rack, and you can make sure that 1,000 people now can use your. Now compute will be the sum of all the computes available, like 256 GB RAM into 10. Okay, and vCores, 100 vCores into 10, 1,000 vCores now you have, and now your application will be able to serve 1,000 people. So this is how a rack looks. Okay, now you are an client, let us suppose. Okay, and you want to book a ticket in IRCTC. Okay, so you have an IRCTC data center where there will be multiple servers. So these icons, whatever you see on the screen, are server icons. So there are multiple servers running. As we saw, I told you, right, you mount 10 servers so that 1,000 people can access it. Now let us suppose there are 3 racks available here like that, and your application is hosted on top of it. Okay, now there is one more person. Suppose I also want to book a ticket. Now you were trying to book IRCTC website, now I also want to book IRCTC website. Okay, so in any data center, before going to server, there is a device, physical device called as firewall. So this firewall helps in blocking one any vulnerabilities, like hackers might try to get into your database and steal data. They might even corrupt it. They might ask you for money to release your website. They make sure that your users cannot access your website so that your business goes down, and they ask for money. And we see a lot of type of attacks. There could be lot many types of attacks, like for data they can get into it. Suppose they want your user data, so you don't want all that to happen. So to protect your servers from outside network, from internet, we use a physical device called firewall. It will have a UI also, like software interface, where you can configure rules that block traffics from particular type of networks. Or we can, if there is a if there is a traffic, sudden increase in traffic, please block the source so that uh, any type of attacks can be prevented. Okay, now the request whatever you give goes to the firewall. Now firewall checks if it's a legit and proper request or not. Now what this firewall does, it has to give the request, it has to forward the request to a device which can give it to one of these server. So what this device is called, it is called as router. Okay, it is similar to the router that we have at home. When we at homes we'll have a router, and you see on the back side of router you will have ports like this. These are called LAN ports, and these ports are given on back side of the router so that you can attach multiple systems, up to 4 or 5 depending upon number of ports you have on your router. You can attach those many number of systems. For example, if you have 4 laptops at your home and you have a router, you can what you do, you don't want Wi-Fi connectivity, let us suppose, and you can connect your laptops using LAN cable to the router so that you can access internet. Okay, so what this router is doing, it is routing traffic from your laptops to internet, and from internet it is again routing it to your laptops. Getting it? For example, if your mobile phone is connected using Wi-Fi, when you say I want to book this ticket, and you go to Book My Show and you click on those seat numbers and you book ticket, the first what it has to do, it has to route the traffic of your request in client server model from client to server. Again, from the response from server, it has routed back to your phone, your client application present in your phone. So that routing is taken care by router in our home. So similarly, in data centers, we have to do routing. We need to make sure that the traffic from internet goes to the server. From the server, it goes again back. But we have two different devices here. So generally at our home, we have a router, only single device. In data centers, we have two devices for it. We have a router and we have a switch. A switch is a device which connects multiple servers. Okay, so this is how traffic is split and happens in data center. It's just an overview. There will be multiple other components, but these are the basic components. So this is how a switch looks like. Okay, it has multiple LAN ports. We have to connect servers to this switch, and we have to configure routing. Okay, so when we'll be discussing about networking, we'll get into deep of how networks are, how to create a, like, what is a backend network, how to create a network, how to divide it into subnets. Okay, if you want to segregate two things, then we have to put two things. For example, we have to segregate application server and database server. We don't want application server and database server to be in the same network for some reason. Then we'll have to put both of them in different subnets, and we will go and we'll study what are VLANs, how to configure that. We'll see all that. And this is how a router looks. Again, this is also thin box type of instrument, and this is how router looks. This switch is connected to router, like as you saw in diagram. From router, request comes to switch, and from there it goes to different servers. If you're adding more servers, you need to get more switches, and we just have to connect it. Okay, router can be one or two, but switches will be more because depending upon your server count. And this is a physical firewall. First the request goes to firewall, then from the firewall it goes to router, from router it goes to switch, from switches it goes to servers. So this is how a firewall physically looks. Just an example that there could be, like, Cisco is the leading producer of all these devices, and there are other companies also who produce networking devices. Okay, so once we configure all the switches and servers, this is how this data center looks. So you might be wondering why there are so many cables in a data center. If you see any image, so those are, like, we need to connect all the servers to switches so that networking can happen. So all these things, we have to have an IP schema. Based on the schema, you need to connect the LAN cable so that we have proper communication among the servers and in the data center. So this is how a data center looks in the right hand image. So when you have a lot of racks, we in a room, we just put it one beside the other, and we have to configure it, and they will serve multiple purposes. Like, we can have a few servers for application, few servers for database, few file servers. If you get a chance, you go and see Google data centers for GCP, G Cloud. So you will be amazed. Okay, so any doubts so far?
Yeah, we are good.
Yeah, so let us get into our next topic, that is virtual. So what is a virtual environment or virtual software or virtualization? So this is our server that we have seen. Now we want to have application on top of it. We want to have database on top of it. We want to have a web server on top of it. Now when we want to have all these three processes running, now we might think that let us segregate these three processes, and let us keep these three processes in different operating systems. For example, we as a team is working. Let us suppose we 4 people are working. Then I will say that okay, you install app server in my laptop, you install database server in your laptop, and we'll ask a third person to install web server in his laptop. And anyway, once we connect everything through switch and router, they all will be in the same network. So this we are doing because we can manage things separately. If some update is going to happen to application server, we can be rest assured that database server is not touched. If some updates are happening to database server, we will be rest assured that application server is not touched. If some updates are happening to web server, then we can be rest assured that database server and application server are not touched. So when we want to segregate this and we have only one server, so what do we do? Like, shall we format the entire server with one operating system and get one more server for the other operating system? So since it is laptops, we have 4 laptops, we are doing it, but server is already having huge configuration, right? 256 GB of RAM and 100 vcores. So we cannot waste, because application server might not be consuming the entire 256 GB of RAM, and we want to have DB also, but we want to segregate it also. So to overcome this problem of formatting one server with one operating system, people came up with the concept of virtualization. So what happens in virtualization? We have the physical machine, we divide it into virtual environment. So suppose we have 48 GB of RAM and 10 cores, we can have 3 different OSs running on top of this one server. Okay, and these 3 OSs, the resources can be distributed. So one VM can have 12 GB of RAM and 2 vcores with 2 TB of storage. Another VM can have 16 GB of RAM with 3 vcores and 3 TB of storage. Another VM we can assign 18 GB of RAM with 4 CPUs and 5 TB of storage. So this we can achieve, we can configure, we can get, so that we'll have 3 different OSs on top of one server. These 3 OSs will be independent of each other. So we have one operating system, one Windows VM we have, and on Windows we make sure that our application is running. On another Linux machine, we will make sure that our database is running. In another maybe flavor Mac OS, we make sure that our web server is running. So irrespective of OS, we can have it on one physical server. So what is that which has enabled us to get here is the software called as hypervisor. So it is a technology, it is a tool, hypervisor, which enables us to run multiple VMs on top of a server or on top of a OS. So we can run OS on top of OS. So hypervisor is also a type of OS on top of which we can run different types of OS. Okay, you getting it? So this is how it is. So if we have suppose 4 servers, physical server, we can have multiple virtual machines on top of it. So we will see practically how we can achieve it. Like we can make our laptops to run different OS on top of it. So in our laptop, if you have Windows laptop, we can make sure that you have another Windows OS running on it, or Linux OS running on it, so that we can do different configurations. You're getting it? Now to achieve that, we need to do something. Now, so what is virtual? I'll explain what we have to do. So in virtual machine, we can have a host machine, and top of that we can have different types of operating system with different memories and CPU. So to put it in a structured way, a virtual machine is a virtual environment that functions as a virtual computer system with its own CPU, own network interface, and own storage. So even network is divided logically. It's not only the CPU, memory, and storage. Even network, we'll have a virtual NIC cards for each of the VM, and traffic will be routed. Uh, you know, Programmatically, the traffic will be routed so that all the three VMs function independently. We will actually implement and see. I'll make sure that we all implement in our laptops, and we will need virtual machines to understand more topics, to practice more. Suppose you want to practice CentOS, you want to practice Red Hat, we want to practice Windows Server. We cannot be formatting our base laptop for doing all that, right? So for that, we use same virtualization concept in our laptops, and we put VMs on our laptop so that we can work on different OSs without changing our base OS. Okay, so and there's a software called hypervisor which separates these resources from hardware and provision them to VM so that each VM can use it. And so hypervisor treats the resource as pool of resource. So whatever resource is available on your host machine. So a host machine can be a server, host machine can be your own laptop. So each laptop can have multiple VMs running on top of it. So it could be a host machine or a server, and this hypervisor software treats as if it's a pool of resources, and it assigns it to VMs based on our configuration. Okay, clear? So what we have to do to run virtual machines on our laptop, we have to enable virtualization in laptop. So tomorrow I'll show you exactly how to boot a Linux VM. So Windows VM will, if time permits, will cover, but first we need to boot Linux VM because most of our practical sessions are going to be on Linux VMs. So tomorrow, in tomorrow's session, I'll explain how to boot a Linux VM, and what are the few basic activities that we have to perform to get started. So for that to happen, we have to do two things. First is we need to enable virtualization in our laptop. So if you have time today, you go back and you do this enabling of virtualization in your laptop and download a CentOS 8 image. I'll give you a link. You can download it from there and keep it. So if you're not getting time today, you can do it over the weekend. But you make sure that you do it by Sunday, so that from Monday, if something is there, you can open your own virtual machines and you can start working. So how to enable virtualization in your laptop? All you have to do is you need to go to your BIOS setting. So it could be different for different types of laptops. So for ThinkPads, for Lenovo types of laptops, it is there in BIOS in configuration. In again, models, in different models, it will be there. You need to go there and you need to enable the virtual technology or virtualization technology. It will be there with different names. V technology. So all you have to do is just Google it, like um, how to enable virtualization in Lenovo, your exact model number, or Dell. Okay, for example, if you Dell, you just have to go to press F2. I cannot show it here because it will be booting. It's when it boots up, you need to do this setting. You just have to go to virtualization and enable it. So you type your model number in Google, and you make sure that you enable it. So if you are facing any difficulties, I will rectify it tomorrow, or mostly tomorrow or Monday. Okay, if you are doing it today, good. If not, if you're doing it over weekend, Monday we'll fix it. Okay, so yeah, so this is the link where you can go and download the CentOS 8 ISO image. This is 6.6 GB. I'll just give the link and you can install that. You getting it? So let us just come back to our slides. So today we have covered so far client server architecture. What is a client? A client is any computer hardware or software device that requests access to service provided by a server. In a client server architecture, client interacts with server by making requests for data or resources that client is not capable of providing. So this is a client server architecture where client requests for something to server and server responds it back. Example of this could be you booking a ticket in which you want to book some seats, then the application which is there in your mobile is requesting server for booking those seats, and your server is responding to the client saying that this whether it was successful or not. And you need to get into what are the types of clients which are there. Now next topic was what is server. The server is a computer program or device that provides service to another computer program and its user. So what are the types of servers available? These are the types of server available. We discussed in detail what these do, and we discussed what are protocols, how client and server communicate between each other like we are doing, and you can go back and check what are other types of protocols available and how do exactly they function. Okay, then we saw what is on-premise. This is a CPU example, and this is how a bare metal server looks, and these are some ports and slots for bare metal servers to connect different uh, different type of things like CPU, mouse, different output devices, input devices, network devices. To connect all these things, we have different ports. The usages, you can go through it. And then we discussed what is a rack, what is a server rack, and how servers are actually placed in rack in the industry, and how a rack looks, how a server rack looks. And then we discuss an example of simple data center where request goes, whenever a request to a particular website goes, it always lands on the firewall. Firewall is responsible for routing it to whether it will decide whether you should be given access to the request or you should not be given access, depending upon few rules, set of rules that we configure there. And once it finds that okay, this is a legit request and this should be moved forward, it gives the request to the router, and router with the help of switches, it routes it to the servers. So all this routing happens using protocols. There are different types of routing rules available, like static routes, dynamic routes. So all this we'll discuss when we are going through networking concept. So for now, you need to just imagine that the request flows from user to firewall to router, switch, and then server. And again, the response from the server goes from switches to router to firewall to the end user. So this is how a typical data center operates. So in one rack, whatever we have seen there, we will have all the types of devices. We will have servers in the same rack, we will have switches in the rack, we will have routers in the rack, we will have firewalls in the rack. So one rack, we will have all these devices. So all these devices, mostly they look alike because they can be put in a rack. Okay. So this is how it looks after we put servers in the rack. So what is virtual? So one server, one piece of server, if you want to run different applications on top of it, and we want to have a segregation, OS level of segregation. Suppose I want to make sure that my app, my DB, and my web server run in different OSs so that their environment is different. For example, I can have a DB server running in Linux, okay, and I can have a application server running in Windows, and I can have a web server running in macOS. So these kind of architecture, when we want to achieve, when we want to segregate applications, when we want to segregate OSs, okay, on top of a physical server, because one server is very costly. Okay, and when you get one server, you don't obviously you don't want to be using it only for particular purpose. You have to use it for multiple purpose so that you get the best output out of it. So then there, in those kind of scenario, we go for something called virtualization, where we have multiple VMs running on top of one physical server. So, and what is the software which is enabling this to happen? Hypervisor is a software which is enabling this to happen. So what are the different types of popular hypervisors in the market? the most popular hypervisor in the market is VMware. So if we format a physical server using VMware hypervisor, we can have different operating systems or different VMs running on top of it. Okay. The next popular is Hyper-V. Hyper-V is the hypervisor from Microsoft. We all have by default, like I think Windows 10 has it in, we need to add that feature, program and feature to get that hypervisor, and we can run VMs on top of your own laptop. Okay. And by the way, Azure also uses Hyper-V in the backend for all the VMs that we are going to create. For all the virtual machines, when people say, right, we have to create virtual machine in cloud. So this is what we mean. When we go and click in console, create a VM, the Azure will create a virtual machine for you in one of their hypervisor. Okay, it will also have data centers. Azure also have data centers, servers. So it will have hypervisors running on top of it. So when you request for a particular VM, it will create on one of its server and it will give you access based on your network, your your credentials, your region. So we'll have different regions. So if you want to create a hyper VM in East US, so we will so Azure will make sure that in one of the data center which is present in their East US region, your VM will be hosted in their physical server using Hyper-V, and you will be able to use it, and you will have to pay Microsoft for running it. So so we pay for only what we use. So it's called pay as you go service. So as long as your VM is running, you have to pay the cost to the data center. Okay, we'll discuss all that. So you just have a general idea of what is hypervisor now. So once we enable the hypervisor, we'll be able to have different OSs on top of host machine. So all you have to do is in your laptops, I just hope that everyone has Windows. Are you using any different type of laptop also? Then just Google it how to enable hypervisor for virtualization for your laptop and just enable it. And downloading image, you can do it over weekend, but you just Google it and keep it so that if you're facing any issues, we can get in and we can troubleshoot. Okay, so this is an example. If you are using a Lenovo laptop, this is how you will get the screen. Okay, so I think that's it for today, guys. Any queries, any questions? Did you get whatever I was trying to explain?
Yeah,
Anindra,
Fanindra.
I have one question. Do we get
Yes.
SRE level training in this course?
SI means?
SRE.
Okay, yeah, I think I mean they do pretty much these kind of activities will touch a lot of they call it site reliability engineering. I mean all you have to do in there is you manage their servers and create a VM or migrate it to cloud. So once you go through this course, I think we might not be touching all the concepts, but we'll touch a lot of concepts which will help you to learn if there is something else also. So for example, we might not be covering VMware UI, but you will know Oracle VirtualBox UI or Hyper-V UI. These two are the UIs which I am planning to cover in our this one. So when you go to site reliability engineering, you need to ask them what is their environment hosted in. Suppose a client's environment is in VMware, then you just have to see how to create a VM in VMware, or you might be working on migration projects from on-premise to cloud. So they might be using some software which you have to learn, but you will have all the basic knowledge of to pick up those concepts. So you'll be able to tell them that you know how exactly a server works, you know how exactly a data center works, you know how exactly a on-premise works, you know the network architecture, you know the VMs on top of it, and given a software, you'll be able to perform the job. So not exactly that role, but yeah, you will have the concept to get into that role.
Okay. Okay. So you are also telling the you'll be telling the DevOps tools also, or the basic of tools.
DevOps
I
tools
mean,
also. We will see. We will we will create an application. We will push it to DevOps. We will create pipelines. We make sure it runs in app service in Azure. We make sure it runs in AKS in Azure. So these things we'll do. We'll actually make you do.
okay. So will you have touch in the Jenkins and
No,
Ansible?
we will not be. No, we will not be using those because we want to focus mainly on Azure DevOps. So the alternative for Jenkins here is we have pipelines here. So I'll explain you how to write pipelines in Azure DevOps. So it's just an alternative for that. So we'll be focusing more on Azure DevOps tools.
Okay.
So again, if you have an idea on Jenkins, then you'll be able to integrate it with Azure DevOps. I'll explain you that basics. So if some project has having Jenkins, how do you exactly integrate with Azure DevOps, Azure repos? So generally, people who have Jenkins, they don't use Azure DevOps. So but now currently they're migrating it to Azure DevOps because you can use Azure Cloud with Azure DevOps. So that advantage you're getting. So we'll discuss about all that. So why are they migrating from Jenkins to Azure DevOps? What is the advantage? So the advantage is that it comes with cloud, so you can directly integrate your pipelines with the deployment. And yeah.
Hi,
Uh,
Faiza. Uh, Suraj here. Hello.
Yes, hi Suraj.
Uh,
Hi
uh,
Suraj.
basically, uh, today is my first class, and I don't know about what the topic will be cover in the entire session or the entire training session. So, can you explain me once what the topic will be covered in for last 1 month or 1.5 month or 2 month, whatever the tenure of
Yeah,
this training session?
yeah. I just opened the slide. Actually, I gave this presentation. I think yesterday, day before. One second.
Can you inform me? This one is the first session, or the many other session has been passed?
This is the first session. I just took a demo session in which I explained what we're going to cover in the sessions.
Okay.
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 So
Okay.
in
Let
the
me.
contents, first we'll go to introduction and evolution of cloud and DevOps. So we'll see how we came to cloud. So first, for that, you need to understand history. What is data center? What is virtualization? What is VMs? All that. From there, we'll be able to
Okay.
pick up. Next, we'll go to OS basics. We'll go to Windows Server basics. We'll see Linux Server basics. We'll focus more on Linux Server basics because that is going to be there with you forever. Because as long as industry is there, Linux is going to be there. So we'll cover both
Okay.
Windows and Linux basics. Then we are going to cover networking basics. We'll see what is subnetting, what is network, what is CIDR, what is VLAN, what is what is Class A, Class B, Class C, Class D IP addresses. We will see what is the public IP address. We'll see networking services like DNS service, DHCP service. So all this will cover in networking basics. Next, we cover storage basics. This is going to be very small. I'll just explain you how storage works in a data center. Typical, what is iSCSI, what is LUN, all these things. I'll just explain you overview. So that see all these I want to cover so that when I'm explaining things in cloud, you will be able to correlate how things were and what things are in cloud, so that even if your cloud provider changes tomorrow morning, if you are given to work troubleshoot something in Azure, sorry, something in AWS and GCP, you should be able to pick it up because these are the basics which is put in cloud. Okay, this is what are the basics and these are what used there. Then we'll see basic software services like what is an app service, what is a web service, how they function. Okay.
Okay.
We'll take few examples and see, and then we'll see what is Docker and Kubernetes. We'll get into details of why they came, what are they doing, how is it useful, how are they working, in cloud today. Okay. Then we'll go to introduction to Azure. We'll get into Azure. We'll check Azure Active Directory. We'll see how networking is happening in Azure. We'll see Azure Storage. What are the options available? We'll see Azure PaaS services and we'll see Azure DevOps. So if you see the previous slide and this slide, it is like the cloud equivalent of the on-premise things that we will go into practice. Understand? First, we'll practice everything in on-premise in our laptop. Then we will see what are their cloud alternatives, or how is it happening in cloud. And then we'll see Azure DevOps. Azure DevOps is going to be again separate completely. So I think some 30% of classes are going to be on that, so that we can focus more on the pipelines, how to write a pipeline, how to write pipelines in different languages, how to build it and push it to AKS, how to build and push it to app service. Okay, so you might encounter more likely to any one of the scenario when you get into job. So even though if you are encountering something really different, I am sure with the basics that we are going to learn, you should be able to pick up. Okay, so by the end of the course, you will get an understanding of why IT industry today is the way it is, and then what is a work culture, how things will be. So when you get into a team, you should not be like you do not have experience. The way you talk should be like you're talking as if you got some 4-5 years of minimum experience when you get into that job. And then how to pick up a DevOps technology and master it. For example, we might not be covering Jenkins, but with the with the concept that we have now, you should be confident enough that okay, let it be Jenkins, I'll just pick it up. It will also have few basic fundamental functions like other DevOps tool. So let me find out how these functions work in Jenkins. For example, how a pipeline works in Jenkins, how to write a CI pipeline in Jenkins. You know how a CI pipeline works in Azure DevOps. You just have to figure out okay, where to give the source in Jenkins, where to give the agent in Jenkins, how to configure that. So that level of understanding, that confidence you will have, you should be have, and then you should be able to pick up any cloud and master it. So once you know that okay, this is how networking is in general, this is how networking is in Azure. So let me see how networking is in GCP, because it is not going to be something very out of the box, because they cannot change the basics of networking. No, even Google cannot change it today, because networking is networking. If something works that way, it has to work that way. You cannot make a device work in any different way. Only thing is they can change a UI, they can optimize it for better performance, they can give you better features with less, but the basics are going to be the same. You can say that okay, let me see how it works in AWS. Let me pick up and check how AWS networking works in AWS. Let me see how Kubernetes is working in GCP. Let me see how Kubernetes is working in Azure. So that confidence, I think you should be able to get, and you should be able to have good knowledge on Azure administration, because that is our prime focus. Anything in Azure, you should be able to confidently do it. And then Azure DevOps, you should be able to do it confidently.
So Farindra, are we covering any certifications here?
So after this course, I'll explain you how to approach certification. You'll be able to give exams of AZ 900, AZ 104, and AZ 400. So I'll explain you how to. There will be few things which you have to specifically read for certification, and it will be easy. It will be like a piece of cake for you if you finish this course. You'll be easily able to crack those.
And sorry, Farindra, can you introduce yourself, please?
So I am Panindra. Um, Currently I work for Accenture. I worked for Capgemini. I worked for L&T, Infotech, and I have an experience of training more than 1,000 freshers. So whenever a fresher comes from college to our organization, I have done organization level trainings to onboard them to projects, to explain them how IT industry is and all these concepts. And I worked on Linux, Kubernetes, Docker, and application services, networkings. Then I worked on cloud, Azure, GCP. And how things are, how to set up, how do we migrate from on-premise to, I worked on migrations of on-premise to cloud. I worked on authentication services, worked on different languages like Java, Python, and also not much of coding, shell scripting, automation. So that lot of tools that and domains that I worked on. So lucky to have that kind of exposure in the industry. So
Yeah,
I make
nice to
sure that I give you maximum knowledge that I have gained to you, so that practical knowledge is important. You can go and get, and I can give you a direction. So if you're stuck somewhere, how do you troubleshoot a problem? So
yeah.
all that we'll discuss in any given scenario. So that's pretty much about me, guys.
Oh, okay. Thank you, Fanindra. Nice to hear about you.
Hi, Parindra. Basically, I work as a tester. So, is there any need of to learn the language as well for the DevOps?
No, not required, not required. Because Azure DevOps is independent of any language. It is independent of tools as well. You can integrate new tools, third-party tools. So all you have to know in Azure DevOps is how things are the way things are. Okay, so if you have a pipeline, it can be of any language, but you should be able to open pipeline, and all pipelines will do few basic things, like it will be building, it will be testing a code, it will go through vulnerability testing, it will go through sonar cube testing, and then it will go to a CD pipeline. In CD also same things will happen. It will deploy it into some environment. So it is irrespective of language. So if you understand what these are doing, any language you can have. So I'll show you how to create pipelines for popular languages that are being used. So more likely you are going to, if you get into this domain, you like more or less you're going to have this you know
Like,
encounter.
you are saying like pipelines means Fanindra. So once the pipelines are placed, means we can send the water or oil or anything else.
Sorry, yeah,
Yeah,
correct.
once the pipelines are placed, we
Yes,
can import or export anything what we want, like oil,
yes.
water,
The
gas.
pipelines, yeah.
Yeah,
So no,
that's what
no.
you are.
For each language, we need to write pipelines in different ways. So I will cover most of the languages which you are most likely to encounter. Like we'll cover pipelines for .NET, pipelines for Python, pipelines for Java. So all this we will cover, so that most probably you are going to land up in a project where they will be using this, what they are currently like most popular things. So if you land up in some other, you need not panic, because with the knowledge that you're going to have, with the practice knowledge, you should be able to easily Google and understand how pipeline is written.
Okay, okay, got it.
So I'm going to give you a direction in which you can actually get in. Okay.
Okay.
Okay, okay, fine.
So any other queries, guys?
How much time taken for this complete training session? Is it?
We'll do 40 to 45 days. So unless I am not satisfied that you guys have got all the knowledge that you require, I am not going to stop. So it is going to be between 40 to 45 days, and daily 1 hour, Monday to Friday.
Or no weekends.
No, because weekends you need to practice, right?
Yeah, okay.
Yeah, okay.
Because few people might be practicing it on a daily basis. Like whatever assignments I've given now, so types of clients and all, few people go and do it today itself. Few might pile it up till weekend. They might go through all my sessions again Monday to Friday and collect all that and do it on weekend, so that we'll discuss on Monday
And the
about,
timing will be the same from
yeah,
8 a.m.
yeah, 8 to 9 will be the timing.
Okay, okay, it's fine.
Okay. Any other queries, guys?
So we will know how to take the subscription also.
Yeah, I will explain you. You will get a free subscription with $14,000 credits. So I'll explain you when it is required, so that you use it wisely.
Okay.
Okay, I think someone from Accenture too. Good. I'm not sure how many demo classes, because demo we already finished. This is the first session. So from tomorrow I'll continue from this session. Like tomorrow's class is going to be the continuation of this session. Okay. Yeah. Anything else, guys? So I'll treat everyone as fresher because
And
yeah.
mm, how can we enroll in this batch for the next?
I think you need to join the same link tomorrow. I think they're collecting email address and I think phone number so that they can reach out to you in the chat.
Okay, okay, sorry.
Okay, guys. If nothing, we can drop off. Let's see you tomorrow. Okay.
Okay. Thank you, Fernando.
Thank you. Thank you so much, guys. Thank you. Nice talking.